All right, welcome back to our flipped classroom. And today we're just going over the practice problems so you can check your answers. So I'll just walk through the process for each of them. So our first problem, we have xenon reacting with fluorine to form xenon hexafluoride. And so we're going to make our T-chart. So on our reactant side and our product side, we only have two elements, xenon and fluorine. So on the reactant side, I have one xenon and I have two fluorine. On the product side, I have one xenon, but I have 6 fluorine. And so I need to figure out what I can multiply my compounds by in order to make the number of atoms of each element on each side be the same. And this one's pretty simple and straightforward. I have 6 fluorines on the product side. I need to have 6 fluorines on the reactant side. So I'm just going to put a 3 here. Now I have 3 times 2. That gives me 6 fluorine. Now remember that we cannot change that subscript. We have to keep that as a 2 because fluorine is a diatomic molecule and we have 3 of that whole molecule. All right, taking a look at our next problem, we're going to go through the exact same process, just now we have 3 elements to keep track of instead. And so I'm going to make my T-chart, reactant side, product side. I have silver, I have hydrogen, and I have sulfur. On the reactant side, I have 1 silver, I have 2 hydrogen, and I have 1 sulfur. On the product side, I have 2 silver, I have 1 sulfur, and I have 2 hydrogen. So the only thing that needs to be fixed is the silver. I have 2 on the product side and only 1 on the reactant side. So again, a pretty simple fix. If I put a 2 here, now I have 2 silver and the numbers are the same on the reactant side and the product side. All right, walking through the next couple of problems. This one gets just a little bit trickier because now we have 4 elements and we have oxygen in multiple compounds. So again, we're going to make our T-chart, reactant side, product side. I have potassium, I have oxygen, I have hydrogen, and I have carbon. So on the reactant side, I have 1 potassium, I have 1 plus 2, so I have 3 oxygens, I have 1 hydrogen, and I have 1 carbon. On the product side, I have 2 potassium, I have 1 carbon, I have 3 plus 1, so I have 4 oxygen, and I have 2 hydrogen. So the first thing that I notice is that I have 2 potassiums on this side and 1 on this side. So I'm going to go ahead and try to fix the potassium and see where that puts us. So if I put a 2 in front of KOH, now that doesn't just apply to the potassium. It does mean that I now have 2 potassiums, so that solved that problem. But it also means that I have 2 oxygens plus the 2 oxygens, so I now have 4 oxygen. And it means that I have 2 hydrogen. So I now have 2 hydrogen. And now the numbers are the same on the product side and the reactant side. And I have a balanced chemical equation. All right, so moving on to the next problem. Same process every time. Reactant side, product side, sodium and chlorine are the only 2 elements that we're working with here. I have 1 sodium and 2 chlorine. And on the product side, I have 1 sodium and 1 chlorine. So obviously I need to fix the chlorine. I'm going to do that by putting a 2 in front of sodium chloride. That fixes the chlorine, but it also gives me 2 sodium. So now I have 2 sodium on the product side, but only 1 on the reactant side. So I'm going to come back and put a 2 in front of sodium and make it so that I have 2 sodium on the reactant side as well. And now my equation is balanced. Moving on to the next couple of problems. So we have iron 2 oxide reacting with carbon to give us iron and carbon dioxide. So T chart, iron, oxygen, and carbon. So I have 1 iron, 1 oxygen, 1 carbon. On the product side, I have 1 iron, 1 carbon, and 2 oxygen. So obviously I need to fix that. So if I put a 2 in front of FeO, that now gives me 2 oxygens, but it also gives me 2 iron. And so I need to come back to this side and put a 2 in front of the iron so that I have 2. Now we have 2 iron on each side, 2 oxygen on each side, and 1 carbon on each side. And our equation is balanced. Same process again, reactant side, product side. We have silicon, we have oxygen, and we have carbon. On the reactant side, 1 silicon, 2 oxygen, 1 carbon. On the product side, 1 silicon, 1 carbon, 1 plus 1 carbon, so 2 carbons, and 1 oxygen. I'm going to choose to address the oxygen first because the carbon is in 2 different compounds, so I'm going to fix the oxygen first. Since I have 2 oxygens on the reactant side, I'm going to put a 2 in front of the carbon monoxide. That's going to give me 2 oxygens, but it's also going to give me now 2 plus 1, so 3 carbon. Now, because I have 3 carbon on the product side, I'm going to come back and put a 3 in front of carbon on the reactant side. I now have 1 silicon on reactant side and product side, 2 oxygens on the reactant side and the product side, and 3 carbons on the reactant side and the product side. Okay, I went a little bit out of order, so I'm going to jump around here just a little bit. All right, your next problem is iron 3 chloride plus sodium hydroxide yields iron 3 hydroxide and sodium chloride. So reactant side, product side, and we have iron, we have chlorine, we have sodium. And this is the first time we're going to encounter this. Because I have hydroxide as a polyatomic ion here and as a polyatomic ion here, rather than breaking it up and looking at the oxygen and the hydrogen individually, I'm going to write hydroxide as one of my things that I'm balancing. So I have 1 iron, 3 chlorine, 1 sodium, and 1 hydroxide. On the reactant side, I have 1 iron, I have 3 hydroxide because that 3 subscript with the parentheses means that I have 3 of the whole polyatomic ion. I have 1 sodium and I have 1 chlorine. So I can see that I need to fix chlorine and I need to fix hydroxide. Doesn't really matter where I start. So I'm going to start with the hydroxide. I have 3 on the product side. So I'm going to move over here and put 3 on the reactant side. That fixes the hydroxide, but it changes the sodium to a 3. Now, having changed the sodium to a 3, I'm going to come over here and put a 3 in front of sodium chloride. That will now give me 3 sodiums, but it also gives me 3 chlorine. And now we have 1 iron on each side, 3 chlorine on each side, 3 sodium on each side, and 3 hydroxide on each side. And so we have balanced our chemical equation. The next one on your worksheet is aluminum plus sulfuric acid yields aluminum sulfate and hydrogen gas. So reactant side, product side, and I'm going to do the same thing I did before, aluminum, hydrogen, and because I have this polyatomic ion sulfate here and here, I'm going to leave it all put together as the sulfate ion. So I have 1 aluminum, 2 hydrogens, and 1 sulfate ion. I have 2 aluminums, 3 sulfate, and 2 hydrogen. So I'm going to address the sulfate. I always start with the most complicated compound when I'm trying to balance chemical equations. This is the most complicated one. So I'm going to balance my sulfate. So I'm going to come over on this side and I'm going to put a 3 in front of the sulfuric acid. That now gives me 3 sulfate ions, but it also gives me 6 hydrogen. So I'm going to fix the 6 hydrogen by coming over here and putting a 3 in front of the hydrogen. That now gives me 6 hydrogens on both sides. And I still have one more to fix. I have 2 aluminum on the product side and only 1 aluminum on the reactant side. So I'm going to squeeze a 2 in here, and that makes this a 2. I now have 2 aluminums on each side, 6 hydrogens on each side, and 3 sulfate ions on each side. Last problem is the reaction of ammonia with copper 2 oxide to form copper, nitrogen, and water. So reactant side, product side, we have nitrogen, we have hydrogen, we have copper, and we have oxygen. So on the reactant side, I have 1 nitrogen, 3 hydrogen, 1 copper, and 1 oxygen. On the product side, I have 1 copper, 2 nitrogen, 2 hydrogen, and 1 oxygen. I'm going to start where I have an odd even problem here, since I don't really have a most complicated thing to work with. So in order to make this 3 an even number, I'm going to put a 2 in front of NH3. That's going to give me 6 hydrogens. Now, in order to fix that, I'm going to come back over here and put a 3 in front of water, which will also give me 6 hydrogens, but it changed my oxygen to a 3. This also made my nitrogen be a 2. So that solved my nitrogen problem. I've also fixed my hydrogen problem, but I've created an oxygen problem. So I have 3 oxygens. I need to put a 3 in front of the copper 2 oxide. And that fixes the oxygen problem, but it now gives me 3 copper. So now I need to come to the product side and put a 3 in front of the copper. And now we can see that I have 2 nitrogens on each side, 6 hydrogens on each side, 3 copper on each side, and 3 oxygen on each side. And my equation is balanced. If you have any questions, I look forward to answering them for you in class tomorrow.